Let's begin with introduction.
Yeah, okay. So, good evening, everyone. So today we are here for our first online meetup as part of the BIT Pro and PowerShell user group. So we'll be tackling this session, which is themed as scripting to development. My name is Deepak, and some of you might know me from the Facebook user group we have. And a little bit about me, I've been using PowerShell for a while. And recently at work, I have started the journey of making the transition to learning C# for all my development needs. So I would be talking a little bit about that as well. Prateek?
Yes.
And introduction.
Yep. So hello guys, my name is Prateek, and I write a lot about PowerShell on my website readycurious.com, and I work with Deepak. So we thought like it's a good idea to start exploring on this topic on .NET and C#. So we are taking this opportunity to even we are starting our journey, and we are kind of scratching our own itch here to learn C# and .NET. So we thought like it's a good opportunity for us, and as well as replicate the same thing in your career as we proceed learning this language. That's all, Deepak. Take over.
Yep. So we'll start the session by actually looking with PowerShell. Like we'll start with PowerShell, and PowerShell natively offers object-oriented programming experience, and it enables that by using PowerShell classes. So we'll look at what classes are, and we'll get a little bit familiar with what are different members of a class, what we say when we mean a class, and what, like many of you might already know, PowerShell is actually .NET based, and it's an object-oriented shell. But the thing with PowerShell is it actually hides all these types. So it is like it's actually termed as type promiscuous language. The types are there underlined, but it sort of hides it from the end user who just wants to get his job done, right? So for someone who is just a sysadmin or an operations person, it doesn't matter. He doesn't have to look at the underlying types. He just wants his work done. He can come in, open a shell, issue certain commands, and the job is done, right? But if the same person wants to develop some complicated solutions, right, having an object-oriented nature actually helps you write clean and maintainable code. And you would have seen some of the challenges when you write solutions based off PowerShell, that it would have been easier if you could actually like model something as a class or something, right? So so PowerShell lets you do that. Many people don't explore that front of PowerShell. So we'll talk about that. And when we talk about PowerShell classes, I'll also introduce something called PowerShell Notebook, which is actually part of a broader ecosystem called .NET Interactive. So I'll quickly talk about PowerShell Notebooks because I'll be showing those hereafter. So PowerShell Notebooks are nothing, you would have heard of Jupyter Notebooks. So Jupyter Notebooks are nothing but they are essentially JSON files, but what they provide a richer experience to people by providing a web interface where you can actually take notes, execute code, capture what's the output, and that way you can sort of like when you are exploring a topic, you can quickly take notes, execute a PowerShell code, capture the output what is there, and so forth on, right? So in order to get that is very easy. You need Python 3 and Jupyter. So the steps we'll be publishing the repository link. You can find all the links there, and you need to download .NET Core 3.1 SDK. Once that is done, you need to install a global tool with .NET. So .NET has this concept of global tools where it ships some useful utilities inbuilt. And using .NET ecosystem, you can run that utility, right? So for example, here I'm actually installing the .NET global tool to install that .NET interactive global tool, right? And once that is installed, once the interactive global tool is installed, we need to install the Jupyter kernel. So once the kernel is listed, if you actually run this, you'll see something like this. So I've already done this. So if I run this on my machine, you'll see that it lists out .NET C#, .NET F#, and .NET PowerShell as the available kernels on my machine. So this is basically which powers when you are writing code and executing it. And the only thing you need to do is after you have installed all the components, which is one-time job, whenever you want to use Jupyter Notebooks with PowerShell, you just need to run Jupyter Lab. So I've already run it here. So when you run Jupyter Lab, it actually gives you this output where it gives you a web URL link with a token, which you can click on it and it will drop you into a web browser of your choice. And the experience would be something like this. So you can click plus and like create button and it will tell you what kind of notebooks you want. So I can say Python, .NET C#. There are a number of options, right? So what I've done is I selected .NET PowerShell, and if I click on it, that it just creates that. And there are like a lot of keyboard shortcuts and stuff. So if I want to just create a note using Markdown format, I can say notes. I say this is my PowerShell notes, right? So in the past, you would have used something like start transcript. That's what I essentially used to do. Whenever I was exploring a topic, I would go into my PowerShell prompt and say, let's take note, and I would say start transcript, and I would say give it a path, say first day notes or something, .txt, and it will start logging everything. But in order for me to take any actual notes, I had to like put a comment character in at the very beginning. So let me do this. Let me not put it at the root. And suppose I'm actually exploring something. So I would take notes by putting a comment. This is a note, right? And suppose I'm executing something, it will actually capture the output as well, but it's plain text, right? So there's like it doesn't give you many options. Like other person has to just look at that file and figure out what's happening there, right? But with Jupyter Notebooks, the experience is much richer. So which I'll show now. I can hit press enter and you will see that it gives you all the markdown rendering. By default, you are always in a, this is called a shell, cell, and cell you can actually execute whatever you can do in PowerShell. And say it'll take some time. It actually uses the underlying PowerShell host to run everything and captures this. So if you save it and share it with one of your colleagues, if he opens the same notebook, PowerShell notebook, again in Jupyter Lab, he'll have all this context around, right? And this is a fantastic resource, right, when you are learning something, because you can share notes with teams. They can actually execute code, tinker with the code, see if everything's working, right? So there's the entire philosophy of doing operations with like Jupyter Notebooks. I'll not get into that, but certain teams try that, where instead of maintaining flat wikis, they maintain Jupyter Notebooks. So enough about notebooks in general. So this is a PowerShell notebook, right? So let's dive into PowerShell classes. So PowerShell, as I mentioned, is actually a type promiscuous language. It used to hide types, and up until PowerShell version 5, it wasn't like we weren't able to create types natively in PowerShell. So what we were forced to do for most of the time was get an object, and it would be like every object which you get in PowerShell, there's a type adapter system behind the scenes which actually wraps it inside something called a PS object. So if I look at a object, right, when you do a get member of any object, you get the native type being exposed, but there's also a adapter layer, a type adaptation layer, which actually wraps it inside so that it can actually work in PowerShell, right? But you can't create a native type here. So when I say native type, we need to actually go back and compare how does it differ, right? So in my current PowerShell experience, I've been only creating functions, and functions let me do my job. Why should I use classes or create new types, right? So writing functions is like is a different paradigm where it's actually derived from procedural programming. So procedural programming states that if you have a problem at your hand, you'll break it into procedures. So think of procedures as function, right? So for example, in an Azure in Azure context, right? If you want to stop a VM, you would immediately start thinking in terms of tasks you want to do, right, or procedures. So what would first thing would be log into Azure, right? So it would be a commandlet which you can execute, like add -az context, connect -az account. You'll do that, then you'll say get the VM. You get the VM using get -az VM, pass the required parameters, and then you stop the VM, right? So you are always thinking in terms of procedure. And functions are excellent for that, where you want someone to you want to give that native user experience, and people want to execute code and get sort of like get an interactive experience. Functions really excel there, right? And you shouldn't change that user experience, even if you have learned classes in PowerShell, right? So classes, whereas is actually for, you can think of it like not user facing when you're writing your tools. So classes enable us to practice object-oriented programming. So in object-oriented programming, the major difference is that instead of thinking about tasks, you start to think about objects, right? You start to think about modeling the system you want to like automate or you want to work with, right? So for example, VM, right? We were talking about VM. So VM is actually, you can think of VM as a class or think of it as a blueprint around which all of your things matter, right? For example, I was stopping a VM, I was getting a VM. So those are like behaviors on the type VM or that blueprint which I'm talking about, right? So essentially, bottom line is this, like if you are already using PowerShell, always expose functions or advanced functions which you are writing for your end users, but behind the scenes, the complicated logic of modeling the system which you are trying to automate can be done in class. So it can be a win-win situation. So don't have to lose all the things which you are doing at the moment and like throw it into the dump, but it's more about refining your process and writing more maintainable code. So I have kept blabbering about classes, like these are blueprints, right? So in the class, you define what data to store. So class is sort of like a cookie cutter, and class itself doesn't do anything. So what it does is it basically provides you a cookie cutter, and whenever you create an instance out of it, so it's also called as like instantiating a class. So whenever you instantiate a class, you are always guaranteed that that instance which you just created always adheres to your class, like whatever your class you have written is actually an instantiation of that. So it will have all the properties you have defined in it and all the actions or like methods on it, right? So for example, in order to write a very normal computer class, you can just use the class keyword. So I can show you how you would do that in a normal PowerShell or VS Code. So you can write a test class and you can just say, and this would actually create the class for you, right? And what you can do is like you can create a new instance of this class using new, and I can run this guy, right? So it executes this and it just creates a class, right? But what I'll be doing is like using a notebook here. So I'll execute this and you'll see that it actually it executes and it creates a class, which it doesn't do anything, right? Because the class itself is not supposed to do anything. So it's when you actually instantiate a class. So if I run this guy, you'll see that if I run this, it actually creates an instance of the class, which is just empty, like it has nothing on it. So it's just empty class at the moment. So new this static method was added in PowerShell v5. Instead of using the old way of like new -object to create an instance of the class, you can use this, this guy is much faster and it's much easier to pass arguments to it. So new object, you would face some problems if it would require arrays, hash tables as arguments. So it was a little bit cryptic. So the PowerShell team added this static method on any new type which gets created. I think it's called extension method, which gets automatically created on everything, but don't worry about that. just be aware that it's there for you to instantiate any PowerShell class you write. So now through the whole presentation, I'll try to model a computer object because I've been talking about computer objects for a while. So we can say and for right here, what I'm doing is like I have a class called computer and it has a property. Property is like data. So it has a host name and an IP address associated with it. So it just defines the blueprint. It does nothing. So what you can do is like go back and copy this here and then go back and paste it here. So what I'm doing is like this is my computer class. It has a property called hostname. It has a property called IP address, and I can create a new instance of it and then assign these properties, right? So if I run this guy and sorry. So it doesn't do anything. I need to computer and run it. You'll see that I get that object back, which has those properties in it. Right. So I have the object, and you could actually extend this same object the same way you were doing earlier by using add member. So you could add a node property and stuff. But remember, node property is like a sticky node, but these are like actual properties. Prateek will be talking about properties in a while. So these are like actual properties which are defined on a type explicitly. Right. So I've just created a computer class which has a hostname and IP address, and I can specify the hostname and IP address. Right now I am manually specifying this, but you can have like we'll talk about this. You can have an instantiation, like initialization logic, which can set this, but that's about it, right? So what we just did is like create a computer blueprint, a cookie cutter, created an instance out of it, set a hostname and property. It's not very useful, right? So, and you can say like if I contrast this with a function, right? So in function, you could actually take like these can be input, right? Your hostname and IP address for a function or a class. So what you can do is like you can typecast these properties, like the way we used to typecast our parameters in PowerShell. So if I actually do like function advanced, you know that I can say like I could decorate these guys and put a type here, which says, for example, hostname, right? So what I've done is like mention the type of the parameter. So what it makes sure is like if somebody is passing anything else other than string, it would fail for me, right? So that was the advantage of strongly typing everything in, even in when you were writing functions. So let's do that with this guy as well. So I can say this is a string, and I can say this guy here is a string to begin with, but I'll show you that learning C# and like PowerShell classes, how they can help you more as well, right? So now if I run this again, it should work, nothing should change. Everything is working fine. So I'm actually, and I can pipe it to get member to see the underlying types. You'll see that the string source, like this is the type which I mentioned. But what if somebody specified invalid type? For example, somebody said 256 or 356. It's wrong, right? So right now, if I run it, it just runs and it just puts that property here, and everybody knows that it's an invalid IP address, right? So you can do a few things. The easiest thing is like system. You can actually typecast it as something which strongly you can put system.net IP address as the IP address type for this property, and when you try to instantiate this, now you'll see that it throws error. It throws exception saying the IP address cannot convert value to type IP address. So what it basically does, like this string, you try to cast it to that type, it fails. So you've got a very basic validation working for you, which I have to do nothing, right? It's already a type in .NET. So I'm just using .NET types here. I'm not doing anything funky. But you would also remember that, for example, we had validate attributes, right? Right. So for example, hostname in Active Directory domain joined environments can't be more than 15 characters. Or for example, you have a policy which says you need to at least specify 5 characters or something. You can put it this, and you can say this. And for example, if somebody tries to give out very big hostname, you will see that this guy fails, and it gives you a very nice exception saying the character length of 23 is too long, shorten the character length of argument is fewer than or equal to 15 characters, and then try the command. So think about this, right? If you actually start writing classes for things you are doing in day to day, for example, somebody was asking me, right? Somebody was asking me the other day, how do I quickly validate ARM parameters file? So ARM parameters file are basically like input to ARM templates, and they're like, you won't know if a parameter value is wrong until you kick off a deployment. I know you can do a test deployment and stuff like that, but what if you wanted to catch those bugs early, right? If a user specifies something which is wrong, what you can do at the moment is that write a class which models the input you are expecting. Try to take that input. It can be a JSON input as well, and try to create a class out of it, right? Or try to cast it as your class type, and it will give you all those validation errors which we just saw, right? So with a very few effort, I was able to write a class which has a host name, and I'm able to quickly validate, right? And I actually missed showing this little neat trick, which is often referenced in Bruce Perry's PowerShell in Action book. So this is just syntactic sugar. So it's in place to make life easy. So what you can do is just give the class name and a hash table which has all the attributes which are present in the class, and then it will just take that and type give you the instance of that. So instead of doing new and then setting each and every value, you can do this as well, and it will just give you that. So you can quickly validate that it actually creates that, right? SVM1. So this is called cast initialization method. It's just a syntactic sugar for you guys. Like if you don't want to type new and put all those things. So I talked about validating attributes, right? So let's talk a little bit about more about actions which you want to perform. So for example, in my computer class, right, I can have n number of methods, but I'm taking a very simple one here. I'm adding a method called isAlive, which is not a generic function I'm writing. It's actually tied to the model I'm actually trying to work with here, right? So computer has a behavior of like, is it up or is it down, right? So I have added a method called isAlive, which does nothing, which basically just does a test connection, and it uses the IP address to actually ping the machine for 2 times and quietly does it and returns the status of it, right? And the only thing to note here is like how I'm accessing this property which I created here. So $this actually means the instance. So for example, this is just class is just a cookie cutter, right? But for example, I created one object, I created another object. How does I know the IP address on that particular instance? So $this lets me reference that instance which where I'm running this piece of method, right? So return test connection, there's nothing, like I can just run this and you will see right how it will fail. So for host name, let me use the host name binary which comes on my system. Sorry. Here I need to reference the I'm executing host name on my Mac to get the IP address, and I can just run this guy now. And instead of okay, so this is the issue with I think with the PowerShell console. I can need to close it and then run. So let's run it again, or strange. Okay. Let me just click on host. So I think the host name is giving something bigger than the validation which I've put. So let me run this. So you'll see that computer, the object which I created, it can be anything. Like I'm just using localhost and 127.0.0.1 because I don't have any machine. But if I do a get member, you'll see that it has this method which I added to it, right? Apart from these basic ones which automatically are popping up there. So I can say computer is alive. I can say, and it will just do the job, return the bool value back to me. So think of how powerful this is, right? So you can actually add a method which generates an inventory, right? Or which adds a printer, or which starts a VM or stops a VM. So you can add behaviors to it, and that way it's very easy. Like whenever you're coming and modifying code, you know, okay, if I want to perform some, if I want to add a behavior to a computer class, I need to go and modify probably the computer class, right? So like in functions, it's a little bit difficult. You need to exactly see where the actual heavy lifting the code is doing. But yeah, so how we are doing on time. So I think I'm running a little bit over time. So let me quickly talk about constructors. So constructors are nothing but very similar to methods, but with a catch. So whatever is your class name, that is your constructor name. There's no return type. So this thing which I added earlier in my method is the type of object you'll get. And notice how we always use return keyword to return everything. So in functions, you would be doing like write output to write to output stream. But with classes, you always return something back using this keyword return. So you have to always use this. Otherwise, this will complain that you are not returning the value which you are specifying. If you don't have anything to return, you can put it as void, right? And the same thing, computer. This is very similar to a method, but it has the same name as the class, and it does not have any return type. And you can have like n number of arguments to it. And what it does is when you create the instance of this class, this is the first piece of thing which runs. So for example, if on the example here, I'm expecting a string fqdn as the input. And if the fqdn, so fqdn has to have the domain name inside it. If I'm doing a quick validation here, if the fqdn does not contain a dot character, I'm saying specify an fqdn with this vmname.domain.com, right? So I can quickly run this and show you how this guy would work. So I ran it and then I try to create this thing, and remember that I'm not specifying domain.com here. So I'm not specifying like of fqdn. So what will happen is like it will fail. You say you need to specify fqdn. So all the validation logic and stuff which you initialization logic you want to put when you're creating an instance of the class, you can put in a constructor. So I also talked a little bit about classes and a function. So I would say very simple example of this is like I can create a class which has all the properties and methods on it, which abstract all the things I want to do with that particular model, which in my case is a computer object. But I can keep the functions here. So for example, I have written a function here which is test computer alive. So for example, if I want to expose this functionality as part of a module I'm building, I would still come and add a function here, add a computer name, but behind the scenes I would still create a computer instance, because what happens is like when I do this and when I do this, computer call the constructor on this computer class, it gives me all the validation logic which is already there, right? So I don't have to redo, and I'm already using the validate attributes here. I'm also using a strongly typed class here, which provides less avenues of supplying some error-prone values to my code. So if I run this, let me first test this with a bogus value, let's say localhost, and I run this. See, it's still behind the scenes because it's backed by a class. It still has all that validation logic. And if I say give a very big name, domain.com, you'll see still it will fail because first. Okay, yeah, the character length of 22 argument is too long, shorten the character. This is stemming from that validate length attribute which I decorated the property with, and so back and forth. So all the good stuff, right? So let me wrap this up running a successful one. Oh. Interesting. Okay. Okay, I think it's looking for something with the as usual with the but that's the gist of it, right? So don't throw away functions which you're writing, but try to add more classes. And in a while, you'll see that your code actually becomes more maintainable. I know you would have a lot of queries, and some of this stuff actually comes with when you get into the exercise of using more object-oriented stuff in your day-to-day programming or scripting needs. So I will stop by saying that, and time for Q&A. Is there any question and answers? I don't see there are any questions. So I think I'll wait for another 1 or 2 minutes if anybody has questions before Prateek takes over.
Hi Deepak, can you hear me?
Yeah.
Perfect. Thanks for that nice walkthrough through PowerShell classes, Deepak. It was really helpful, and I especially like that feature in Jupyter Notebook wherein you can see your PowerShell code syntax highlighted, and you can also run that code in the Jupyter Notebook. So that was really great. Thanks for that.
Yep. I bet you have something more interesting.
Yes, I'll try.
Yep.
So are there any questions yet?
I don't think so, but people can put them in the chat window and I'll reply it there.
So I'll not wait anymore and I'll begin with the presentation. Okay. So guys, in this next session, we are going to talk about C# classes. This is just an introductory session and we would be covering just the basics. And the purpose of this session is mostly to bridge the learning and concept gap between PowerShell and C#. And we are not intending this session to, deep dive into C# concepts, and which we will cover in later sessions of this series. All right, so let's quickly introduce myself again. My name is Prateek Singh. I call myself as an infrastructure dev. I write on readycurious.com website. My socials and my book details, everything is here on your screen. The agenda of this talk is primarily C# classes. First of all, we will look into prerequisites, what is required so that you can start develop your development journey in C#. A small overview of C# language, what is a compiler, runtime, .NET framework. Then we will do a small hello world using .NET CLI. And then we will use something which is called interactive C# to bridge that gap between scripting and development, because most of the guys who use PowerShell come from a system administration background, and they are used to having PowerShell, which is more of a interactive console shell. So we will try to fill that gap with C# interactive and see how it can help us reach to our goals to learn C#. Finally, we will look into C# namespaces and classes, and towards the end of the session, we will quickly cover how we can use a C# class in PowerShell. All right. So prerequisites to use this, start using C# is you have to have .NET Core SDK. You can use this link, which we will be sharing very soon on our GitHub repository. You can use this link to download the .NET Core SDK. You can also install Visual Studio Code and use the C# extension from VS Code Marketplace. And Visual Studio is optional, but it definitely comes with some unique and good features like C# interactive or csi.exe, which you can further use to enhance your experience and fill that gap. And I've also linked a small documentation here, how to use C# in VS Code. You can also take a look what it is. Okay. So small overview of C# language. C# is a powerful, flexible, and a very modern programming language, and it offers a lot of features. It is very versatile language nowadays. There are almost it can be used to do almost anything which you can think of, from machine learning, from web development, building console application. Even you can use that in PowerShell and build your infrastructure using C#. So let me quickly walk you through the characteristics of this programming language. So first of all, it is modern. By modern, I mean that it allows features like automatic garbage collection, Lambda expression or Lambda functions, advanced debugging, and exception handling. C# is also open source and cross-platform, which means the whole C# and .NET compiler, .NET Core and C# compiler both are open sourced on GitHub, and Microsoft actively manage and build these two on GitHub. You can directly go on GitHub and see the repository, what they are doing, what are the current issues and everything. And since it's also a cross-platform, that means you can create applications which can run on Windows, macOS, and Linux. The most important feature here is object-oriented nature of C#. So since object-oriented programming came into the picture, you started to see features like inheritance, encapsulation, polymorphism, which we can discuss later in this session or maybe the next session, what these exact features are when we will deep dive further into C# and classes. Another important feature is type safety. So C# kind of enforces or limits you to not able to cast to any incompatible data types. So it places all the restrictions, so there is no bugs in your code, and you are not mistakenly running something which you're not intending to. All right. And the next point is modular. Modular means you can segregate your code into functions and classes to make them usable, and structure your project properly and neatly using the modular programming concepts. C# is also secure. You have access to all the .NET classes, which includes advanced encryption standard, which is AES, which is an algorithm to encrypt, and also the data protection API. These are the very popular algorithms which are used for security. And coming back to the final point, robust, versatile, and evolving. So C#, like I said before, it could be used to develop Internet of Things. You can use C# as a language on your Raspberry Pi, or you can use it with cloud applications, database applications, and even Microsoft has introduced something called ML.NET, which is kind of a .NET based machine learning framework which you can use. So in that also you can use C# to run various functionalities and build your models which can further provide artificial intelligence applications. All right, so now we will talk something about compilers, runtime, and .NET framework. So the moment I start talking about C#, and if somebody is a system administrator, the first thing that they will come across is compilers, runtime, how to run this code, and things like that. So I have especially made this section to just walk you through what a compiler is, what is a runtime, and what is .NET framework. So when you start writing your C# program, so let's suppose the name of my program is first program.cs. CS is the extension which we use for the C# files. So this is just a very high level programming language. So I can just write my code into a file with name first program.cs. And when I run this file, what it will do, there is another program called C# compiler. And what the C# compiler does, it basically translates my high level programming language into an intermediate language or assembly. So now my program first program.cs will be converted into first program.exe or first program.dll. Depends upon what is my project settings. Depending upon my project setting, it will automatically convert it into whatever output type I choose. But these are exe and dll are often the default types. So once the intermediate language is created, you have your exe and you have your dll. Still, your processor doesn't understand like what to do with this intermediate language. So that is why C#, the whole from creating a program and to execute till the execution, you can divide the experience into two parts. The first one is the compile time, wherein the compiler comes into the picture and creates the intermediate language. And the second part is the runtime. Runtime is basically a combination of .NET framework, and further .NET framework has a lot of things called CLR, which is a common language runtime, which is basically used to run the application, which uses a just-in-time compiler, and whatever the .NET classes and libraries are available in the framework, it uses all these three to generate a machine code, and machine code is a very low level language which your processor understand. So machine code is basically like instruction to the processor. All right, so this is how your program is executed using a compiler, then converting it to an intermediate language, and then in runtime, using the .NET framework, we convert it to machine code, which your processor will understand. All right, so let's start by creating a small Hello World .NET program and see how we can use .NET CLI to create or scaffold a simple project. And maybe we'll try to tweak and modify some of your code and see how we proceed with it. So first of all, there is a command called .NET new console. So if you want to create a console application, you can use the .NET new command and you can provide an output. Output is nothing but a folder where you want to place your project. So if I run this in my console, you will instantly see that it will start creating all the actions. It will start creating some project, and finally you will see that something is created and there's a file called myapp.csproj. All right, and it is succeeded. So let's go to this file and probably let's try to see what these files are actually. So if I do get child item in this, I see the myapp folder is created. Let's cd into this folder. And now I can see there are two main files available here, which are myapp.csproj and program.cs. So let's open these files one by one and let's try to understand what these files are. So first I'll open myapp.csproj and you will instantly see that this file is nothing but an XML file, which is kind of a declaration how you want your CS project to be, C# project to be. So at the top, it mentions the SDK which we are using, which is the .NET Core SDK, and then it shows the target framework and the output type. So when we choose an output type, it basically tells the compiler that I want an executable to be created. Similarly, you can choose an output path. So let's suppose I want to place the executable into a different folder. So I can define an output folder here as well. Now let's open the program.cs file and see what is there in this file. So this is a simple C# file which is created the moment you create your Hello World console application. So at the top you will notice there is a directive called using, and there is something called system. So if you know a little bit about .NET classes, system is a namespace which is available in .NET, and using the using directive you can call this namespace so that you don't have to fully qualify the classes or the functions of this namespace. So that means if a system is the namespace and there's a class called console inside the system namespace, then if I specify using system at the top, then I don't have to fully qualify my code like this. I can simply use console.writeLine here, and console is a class in system, and writeLine is a method in the console class which we are using, and we are passing some string as an argument to it. So this was using and what it does. After that, you will notice there is something called namespace. Namespace, we'll discuss this further, but it is just a container which can segregate your code. It is basically used to create a separation and neatly organize your code so that there are lesser conflicts, and you can have classes with same name in different namespaces. So it helps you categorize your code properly. So I have given a name to my namespace, and which was just the name of the project we choose, and there is a class called program. And inside that class, I see a method main, which is the entry point of any C# program. So if you want to run your C# program, you have to define an entry point, which is main, and whatever there is inside this entry function or entry method, it will start executing the code from there itself. So you must be thinking, Prateek, what is this static and what is this void? So let's start with void. Void is a return type, which means we don't want main to return anything. Okay, we just want this entry point method to run and not return anything. And this static is used to, it gives ability to this method to be, used without instantiating this class. What is instantiation and what are object, we will discuss later in this demo. So let me just go back to my markdown file. So we have created this we have scaffolded this folder. We have the files in place. There is a CS proj file, there is a .cs file which has the program. Now let's do one thing. I'll copy this code which I have here into the .cs file which I have. And I'll just show you the differences. So there are a little bit differences here. All right. So using directive is same, and you will notice the namespace. I have not touched anything. Namespace is again same. But I have mentioned public just before the class. And I've also mentioned public just before the void main function. So why I am using this? So I'll show you why I'm using this. But before that, I have to remove this code from the top and save my file. Go back to my markdown file. All right, so we are already in the Maya folder. And we have scaffolded all the things which are required. We have placed our modified code into the .cs file. Now I will use a command called .net run. So what .net run does, it basically takes whatever the project configuration you have defined in .cs file and the program, which is the source code, it tries to build it and create the executable and the DLL. So once I run .net run, you straight away see that it was able to identify where is my CS proj file, and it also created a DLL file. And it not only created a DLL file, but it also ran the source code which I defined there in my CS file, which was basically printing a hello world message. Now let's try to do one thing. I will try to load this assembly, the DLL which is created after .net run, into my PowerShell console. The moment I load this DLL, you will see that I see some output on my screen. It shows some version, there is a location and everything. Now, since this is PowerShell, I can start using this DLL, which is a C# code, into my PowerShell. So if I do something like this, which is my app was my namespace and program was my class. Now I can use the program class of my app namespace using this double colon and defining the main method. So if you don't provide like public access modifier in the program.cs, which you saw here, if you don't provide this public and the public just before the void main method, you won't be able to access these classes and the function method in your PowerShell console. So you have to first make them public. You can also verify this by just running this, and it will show you that your class is public. And if it is not public, you cannot instantiate it. You cannot use the methods inside this class. And since we have also defined main as a static method, you can easily use this double colon and call the main method without even creating the object of the class. All right, so this is it. So we looked into like what a C# program is, how we can run it using .NET, how we can scaffold a basic console project using .NET CLI, and how we can go ahead and run the project and create an application. Similarly, you can use that executable which we talked about, and if I can just open that executable as well. So if I go to my MyApp folder and in the bin directory, you will see that there is an executable. I can simply drag and drop this executable in my VS Code. And if I run this, you will see it will again give me the output. So this way you can wrap your source code into an executable and also use it. All right. So now this was a little bit about C#, but again, there is a gap which I feel, and maybe Deepak can also second on this. C# is not very interactive in nature. That means you have to first scaffold a project, you have to create your program.cs file, you have to have your CS proj file, and once you have everything, then you have to run it using .NET CLI to see the results, right? But there has to be a simpler way to use C# more interactively, so that we can play around and fiddle with the code and understand like how everything works. So that is why there are three things which I want to introduce you guys with. First of all, there is a thing called C# interactive window in Visual Studio. So this is totally optional, but if you have a Visual Studio installed on your machine, all right, you can simply go to View menu and you can go to the other Windows menu, and there is a thing called C# interactive in this. So I went to View, then other Windows, and then there is something called C# interactive. So once I click on this C# interactive, you will see I'll get something like this, right? And here I can use anything like C# has or any .NET class, and I can start fiddling around it. So the moment I start typing console, you can see there is a drop down and it starts to understand with syntax highlighting, and it starts to give me suggestions like you can use this class. If I do a dot here, and it shows me that there is a popular function called writeLine with a star. Right, so that is the most used function, writeLine, which sends the output to the standard, which sends the whatever string you provide to the standard output. I can use it here. I can provide a string, something like hey, and I have to mention a statement terminator, which is a semicolon at the end of every line. So once I run this, it will give me the results. Similarly, I can perform any kind of operation, right? Which is 10 divided by 2 is 5, any mathematical operations. Let me see if I can create a loop as well here. So in C#, I can define a loop just like we do in PowerShell. All right, the variable definition is a little bit different. So I'll do for int I equals to 0 and I less than 5. So I want to print numbers from 1 to 5, and I'll simply do I++, which is incrementing the number. And let me try to do something like console.writeLine here. I'll provide a semicolon and I. So if I run this, you'll see that it was able to print numbers from 0 to 4. And this way you can also interactively see what program you are creating. You can try to debug it if you are that kind of a guy who interactively debugs their code. So this is very useful, and this I feel like that is one of the major gaps when you are coming from PowerShell background and when you're going to a C# into C# development or .NET developer role. So this can really help you if you can do that. So this was one thing. So this C# interactive can also be used from any command line. So if I have a PowerShell console with me, and if I have Visual Studio installation path in my path variables, I can just simply type CSI here, and again I'll start to get the same experience. So it will start the Visual C# interactive compiler, and you can again start running your code here and try to fiddle around interactively. And the third point is one of my favorite features which we get. So there is a tool called .NET Scripts. So .NET provides some tools, and there is a global tool which is called .NET Script, which allows you to create C# scripts. So we have heard about PowerShell script. We have created a lot of PowerShell scripts, but what is a C# script? So let's see what is a C# script. So I'll create open Notepad, and I'll create a file. Let's name it test.csx. So the name of the file is test.csx. So CSX is the extension of a C# script. All right. Here I'll do something like I'll define a string. Let's string, and the variable is name. Let me just put in my name here, and I'll do something like console.writeLine, and I'll type hello, and I'll use plus for concatenation and just provide the name of the variable. So once I save this, and I can see that this file is available here, test.csx, right, in my current working directory. I can simply use .NET command line interface with script keyword and provide the name of my file which we just created. So let's see what happens if I type .NET script and I provide test.csx. So the moment I use that and I ran that script, it was able to print my C# program just like a script file. So now if you use .NET script, you don't have to create the project. You don't have to use any IDE. You can just straight, if you have .NET CLI with you, you can just start creating C# scripts and try to fiddle with your code. And if you're just writing a small simple program, that's it. You don't have to worry about anything else. So I am hoping this was useful, guys. Let's move to C# namespaces. So we covered a C# namespaces a little bit in previous section, but let's look into how we can define namespaces. So to define a namespace, you use a keyword namespace, and then you provide the name of the namespace. So this is the keyword, and this is my name of my namespace, which is called demo. And inside a namespace, you can define multiple classes. Okay, you have to just make sure that there is no name collision or anything, and you are good to go. And if you, let's suppose if you also want to define another class with the same name, then you have to create a different namespace to segregate that. So there is no name conflicts in that. All right. And to call a namespace in your program, you have to use the using directive. Okay. Namespaces are logical separation of your code, and they are used to avoid any class naming conflicts. Perfect. All right, so let's also quickly look into C# classes. So Deepak has, went a little deep dive into PowerShell classes. Concepts are almost similar. C# is just a blueprint which gives you a structural pattern. So this structural pattern can be used by anybody once they create an object from this class. So a class can have a cohesive unit. So if I give you an example, if there's a class called car, a cohesive unit can be something like starting the engine or stopping the engine. So anything which is similar should be clubbed into a simple cohesive unit called class, which has same functionality, properties which are similar, and then we can use it as a unit to further scale our project or whatever the real world entity we are trying to build using that program. All right, classes also enforce design patterns. So that means I can define, we only want people to use these properties. So a car can have only 4 wheels. It cannot have 5 wheels. Like this is the truth, right? We can only have 4 wheels in the car. So we can force patterns using class, and there's a concept called struct as well, which we can discuss sometime later. So using concept of classes, we can force design patterns, and it helps us organize our project as it grows. And when a lot of people are collaborating on a single project, it really helps if we have some design pattern or structure in place. And obviously, classes are nothing but some use of object-oriented programming. So you see features like inheritance, polymorphism, function overloading, function overriding, and things like that. Encapsulation. All right. To declare a class in C#, all you have to do is use the class keyword. You have to use the class keyword. You can or cannot provide access modifier. There is a default access modifier, and if you provide an access modifier, it could be public, protected, internal. There are a lot of access providers which are allowed in C# classes, and then you have to, after the class keyword, you have to provide a name of the class. All right. So access modifier basically tells if you want your class to be public, or if you want it to be hidden or private, things like that. You can control that access. So I have this small example of a car class wherein I have made it public. This is the class car. I have used the class keyword and given the name car. You can see there are some properties. Properties are of string type and integer type. String is color. Color can be red. So I can make it default value. So if I provide an assignment operator and provided value here, it becomes a default property for this class. So anybody who instantiate this class, when the object is created, it will have this value by default. I can also specify the speed, which is the max speed miles per hour, as a property. And then I have other things also called methods. So let's not confuse with functions and methods. We can go into the details what these are, but generally speaking, methods are functions which are used inside a class, and a function can be standalone function. All right. So in a class, a method can be something like starting the car or stopping the car. So these properties are characteristics. So if a car is the real world entity and the characteristic of a real world entity is color, so we can define that characteristic as properties. And if that real world entity can perform a functionality like starting and stopping the engine, we can use that functionality or function or method in a class like this. All right. So this is like just an overview of what is the big small structure of a class. All right, and these properties and methods are also called members of a class. Okay, so like I defined, like method properties we can use access modifiers like private and public. We can use the properties, and if I use the assignment operator, that property becomes the default value. Similarly, I can define various methods which can be further used when the class is instantiated. So we talked about class is a blueprint. Now what to do with this blueprint? So what we can do is we can simply create an object of this class. To create an object of the class, we have to first define the name of the class. We use the new keyword. We provide the name of the class, and you see we also provide open and close parenthesis here, and obviously a semicolon, which is a statement terminator, and we assign this to an object. We name it anything, and then there is a type. So data type are also classes. All right, so we can use, since we are creating a class here and we are assigning it to a variable, this variable could be anything. So this class also has that a type, which is again the class type. So let's take this example. The example is just below. So if I use my car class and define an object Tesla, and I can easily, set a type car, because this is the car class, right? And this object would be created using this class. And then to access the members of this class, I can use the dot operator. You can see here, and properties are accessed here, and you can also access the functions or the methods using the dot operator like this. So let me just open a PowerShell console, and I already have PowerShell open with me. Let me just copy and paste this class here. Please note that this is the C# class. We have opened C# interactive window, and I'm just pasting this class here. So once I have this class pasted here, I can simply use one of my examples to create an object of this class. All right. So if I do something like Tesla here, you will see that it has some default value red and max speed set to 200. Now I can also interactively see what are the properties of this class. Like if I put a dot here and I put dot color, if I run this, you can see color here, and similarly I can do with the max speed h miles per hour, and you can see that. You can also access the methods of this class, something like this. So I do something like Tesla.start, like this, and if I run this, you will see that the car has been started. So this is how a basic class can be created in C#, and how you can, interactively use this class to create an object in C# interactive. It could be .NET scripts. It could be your C# interactive window from Visual Studio. You can try to do things interactively and fiddle around how an object is created, how to access the properties and other things. Now we know that we can create a C# class, but can we use a C# class in PowerShell? Yes, we can. It's very easy and simple to use a C# class in PowerShell. All you have to do is define your C# class in a here string or multi-line string. A multi-line string like this, and assign it to a variable which is $C# code for us. Once you have done that, all you have to do is you have to use the add type PowerShell commandlet. There is a parameter called type definition, wherein you define the type. Type can be a class. All right. So I use this variable where I have defined my class in the type definition, and I specify a language to be C#. So let's do that and see what will happen. So I defined a variable called C# code. Now I'll add the type definition here, and once I've added the type definition, I can try to access the class of my C# class which I have just created above and added as a type. But when I try to run this, it throws an error. It says invalid operation, unable to find the program. So you must be thinking like, why I get this error, and I have already added this type. But you are missing one point. We have to also specify the namespace. So if you go above, we have defined a namespace here, which is hello world, and the program class is inside the hello world namespace. So when defining the class, we have to also define hello world dot program here, and then it would be able to identify it as a class. All right. So if a class is defined in a namespace, it cannot exist in separately. You have to use the namespace there. And now I have the static method, which is void here. I can simply use that method in my PowerShell console. And if I run it, you will see that hello world would be printed on my screen. All right. There is also an alternative to create objects in PowerShell. You can also use the new object commandlet, and then you can provide the namespace and the class separated by a dot operator to create the object of this class. All right. So finally, we have one more example here, which is a basic calculator which we have created. And we are going to create this calculator in C#, and then we would be using a here string and using this C# class into our PowerShell. All right. So if you can look closely into this class, I have used the access modifier public, I've defined a class calc. All right. I have multiple methods here, which is again for addition, subtraction, multiplication. But I have used something different with the division method, which is I have defined a static property here. Okay. So what is the meaning of this static thing? When we define static to any of our properties or a method, then it means that property or method can be accessed without creating the object. So let's try to run this code and see if this is what it is supposed to do or not. So I'll copy this from here. I'll clean my console. I'll paste it here. All right. And I will again use add type to add this type definition into my current session. Now I can directly use the calc class because there is no namespace defined. And when I run this, you will see I did a division of 10 by 2 and I see the output 5. But when I try to use add method, the add method was the one. When I try to do a divide method, it will throw an error. Right? It throws an error. You cannot call a method on a null valued expression. And this is happening because I have specified static here. Okay, so to access this method, you have to use it a little bit differently, right? You can directly use it using double colon, but you cannot instantiate this method and then use it. Okay, so I think that's all, guys, for what I have in this session. And if anybody has any question, we could just take a look into them. And then we will have a small announcement of something. All right. Deepak, do you want to add something which I missed, or maybe you have some inputs?
So Prateek, I think the only thing I might have seen out of the way is like you were saying properties, but I think those are fields, right? In C#?
Yes. Yes.
Yeah. So guys, don't worry. We are learning as well. So the whole intent of this is like we are in that journey where we are transitioning to learning C#. Like we have written a lot of PowerShell, but we think, okay, probably this is the time to make that switch. And learning C# sort of opens plenty of doors. Like, believe me, there are like plenty of doors it opens. Just to give you an example, if something is not working in an Azure commandlet, right? For you, you can look at the source, it's on GitHub, or you can use a disassembler. You can get the source, see what it does. If it's not doing what you want it to do, you can write your own. I have been doing this for a while and it has helped me tremendously. Yeah, so there are plenty of examples.
So guys, we have this small announcement to make. So me and Deepak have started writing a book called PowerShell to C# and back. So this book is nothing but our learnings, what we are learning when we are transitioning from a full-fledged PowerShell scripter to more into a .NET developer role. So whatever we are learning, we are trying to document it. All right. So if you see here, we have a link for a free sample. So if you want to learn C#, we have a 50-60 page free C# primer as a first chapter available. Go ahead and please download this sample and read it through. You will definitely like it, and it will give you a bigger picture of what C# is and how to use this language. All right. The whole intention of this book is to bridge the gap between the scripting language like PowerShell and a modern programming language like C#. And sometime back, I wrote a book, PowerShell Guide to Python. And the most common feedback then was to write a book which would cover PowerShell and C# because it makes sense. So if you have worked on PowerShell, you know .NET classes. Now, next cool thing should be C#, and you can use it with Azure DevOps. You can use it with cloud computing platforms like Azure. You can use it for machine learning, AI, and anything. So go ahead and download the free sample of this book, and I'm very sure that you will enjoy. Deepak, you have any comments on the book?
Yeah, so this book is not something which you'll see like a C# primer kind of a book. So our intent is like how we started all this experiment, right, and how we are learning something. So whenever I pick up a topic in C#, first thing I do is like try to do it in PowerShell. That's what I do, because I understand PowerShell a little bit more. And when I do things in PowerShell, I'm able to correlate that, and then that really helps me in absorbing that topic, right? So that's what we are trying in our book. Like we are doing sort of like, okay, this is the new concept in C#. What is the equivalent concept in PowerShell? Is it available? Is it not available? Put that in a code sample as well. So most of the samples we are trying to write in the book, you will come to see that we'll be adding more free sample chapters. So what we are trying to do is like write a class which models a computer system or a AD user, right? Because those things are the ones which people who use PowerShell tackle day in and out, and those are things which people are more aware of. So we are taking an extra effort, we are going an extra mile to make sure that the examples we use are relevant and they really strike home.
And probably Deepak, you should also take a minute to appreciate the the logo of the book, which is the yin yang.
Yeah. So Prateek designed this logo, which is awesome because it represents yin and yang. So yin and yang is like light and dark. So everything has to be balanced, right? So think of PowerShell as that language which can let you do great things in the operations or sysadmin space, right? But you need to know a little bit of C# or the Yang, right? Because then you can really understand how everything is built, the things you are consuming in PowerShell, or you can build your own. So you know both. You need to know both sides of the world to actually do something like awesome. So
yep. And I think one point I want to add here is like they both complement each other. That is why yin yang makes more sense. So you can use PowerShell in C# in PowerShell, and together you can build awesome applications. So that's all, guys, from my end.
Yep. So expect a few more free sample chapters we'll be adding. I think one on PowerShell classes, probably, which will be very similar to what we did here today, like PowerShell classes and C# primer.
So the C# primer we have covers everything, basics of everything, like the programming language elements, whatever we discussed, what are program assemblies, namespaces, and conditional statements, how to define classes, array, objects, everything. And you also have some key pointer exercises, summaries, exception handling also defined in the free chapter. All right. So I think, Deepak, that's it.
Okay, thank you so much, Prateek and Deepak. And thank you all for joining this session. This session is being recorded and the recording will be shared in the same link where this session was, published, right? And be ready for the next session as well, and you will see the announcement soon.